Now I know what you're thinking. You're thinking, all right, I hope I don't have to learn how to solve a system of linear equations when there's three of them and three unknowns. Yeah, you might have to do that. So let me help walk you through that and kind of help you develop a strategy so whenever you're faced with one, at least you have a clue of how to proceed. So first thing I want you to notice is that I have three equations and there's three unknowns in that. So I have a system of linear equations. I just labeled them for our benefit right now, 1, 2, and 3. So when I talk about them, we know what we're looking at. So how do we do this? Okay, our strategy, and there's many ways to proceed, but our strategy is we have a 3 by 3, three equations and three unknowns. And we want to somehow modify and manipulate that to become two equations and two unknowns. Because we already know how to solve a 2 by 2. We reduce that to a 1 by 1. So what can we do here? Well, one method here is that I'm going to look at combining. I'm going to look at, is there a way that if I combined in such a way I can get a variable to drop completely? So I'm going to combine equations 1 and 2. So watch what happens. I'm going to take equations 1 and 2. And I'm just going to kind of keep my marking just so I don't lose track. So that was my equation 1. That was my equation 2. Then from there, I'm going to look at my z's. I could look at anything, but my z's look like it might be the easiest to drop out. So if I were to do that, I could use my addition method by multiplying the second equation through by a 2. Yeah, a 2 is what I want. And so that being the case then, my new system, and this little secondary system here becomes 5x minus 2y minus 4z equals a 3. Boy, it's going to be easy dropping variables and signs and stuff, so I got to be careful here. 2 times a 3x, 6x, 2 times a 3y is a 6y, plus 2 times a 2y gives me a positive 4z, or sorry, 2 times 2z produces a 4z, and then 2 times a negative 3 produces a negative 6. So there's my system. I still have equations 1 and 2. Nothing's really changed. I just modified them, but it's still my first two equations up here. Now let's add them together. So I have 11x plus 4y. The z's drop out, and then I have a negative 3. So what I have is I have a new equation, two unknowns, one equation and two unknowns. And I'm going to mark it as a 4. I have a new equation here. All right. So I need to find another equation, preferably without a z, that I can put in this as well. So the first two times I looked at those two. So let's just look at the second two, and let's see if we can modify those such that the z drops out. So let's take equations 2 and 3. Again, just for clarity, I'm going to say, just let us know that this was my original 2 and 3. From here, if I want my z's to drop out, which was the idea here, it looks like I need to multiply the top one by a 3 and multiply the bottom one maybe by a negative 2. All right, let's see what happens when I do that. My new equation number 2 becomes 9x plus 9y plus 6z equals a negative 9. The bottom one becomes a 4x minus 10y minus 6z equals a negative 6. And again, that was still equations 2 and 3. Here, let's add those up. I would then get 9x plus 4x, which is 13x, minus a y. Z's drop out, equals negative 15. So combining two other equations, I was able to produce a new a new equation with just two variables. And I'm going to call that my 5, and I'm going to put my 5 over into this new emerging 2 by 2. So notice, and let's just back up and see what we've done here. We started with a 3 by 3. All of this work I've done so far was to get to a point where I have a 2 by 2. How did I get the 2 by 2? I just chose one variable that I wanted to strategize and eliminate. I chose z. You could choose x or y, doesn't matter. I chose z, so I had to choose a combination of two lines to eliminate a z. I chose 1 and 2, and then I did it again with 2 and 3. I could have also done it by combining 1 and 3 as well. Lots of ways to get to where we're going, but our strategy was to reduce a 3 by 3 down to a 2 by 2. What do we do from here now? Well, let's look at our new 2 by 2. I'm going to put a little squiggly on it because it's special. We finally got all the way there. So I want to reduce that 2 by 2 to a 1 by 1. How do we do that? Well, let's eliminate a variable, and it looks like if I multiply the second equation by a 4, multiply all the way through by a 4, Four times 13, 26, 52. 4 times negative 4y is a negative 4y. 4 times negative 15 is negative 60. Remember, these are still my equations 4 and 5. Add those together, I get 63x equals negative 63. Whew, how about that? That was kind of cool. And then solving that, I get x equals a negative 1. All right. I want to say we're 1/3 of the way there, but we're probably a lot farther than that. But let's take that and let's just make that 1 shine. We know we're going to have 3 numbers up here, and we found the first one, which is a negative 1. All right, how do we find the next variable, the next one? Well, let's take our solution from our 1 by 1 and plug it into any one of our 2 by 2s to find the other variable. So if x equals negative 1, let's just plug it into number 4 right there. So that becomes 11. And just remind what I had. This is my fourth equation. And I'm going to use 11 times my negative 1 plus 4y equals negative 3. Solve that. Negative 11 plus 4y equals negative 3. Add the negative 11 to the other side. Gives me a positive 8. And y equals 2. All right. That was fun. So I have a 2 up there now. Now how do we solve the next one? Where we're missing a z. So let's take both of our two values, our x and a y, and plug them into any one of our modified 3's. And it looks like it's up here. And which one do we want to do? All the equations look the same. Let's just plug it into the third one there. The third one was negative 2 times my x, which is negative 1 that I discovered, plus 5 times my y, which is a 2, is something that we learned, plus 3z equals a 3. So there's my third equation. I substituted my values of x and y in for those values of x and y with the goal to find out what my value of z is. Negative 2 times a negative 1 is a 2, plus 10 plus 3z equals a 3. 12 plus 3z equals 3. Subtract 12 gives me a 9, negative 9, and a z equals a negative 3. Looks correct. And then I have what appears to be my solution, negative 1, 2, and negative 3. In order to find out that solution, I should substitute that in to the other two equations of my initial problem to see if it all checks out, to make sure I did not make a mistake. And you can see why you would make a mistake. There's a lot of little tedious work, but it's easy work. It's just tedious. And because of that, we may make a mistake. So please use some paper on this. Take your time and learn the strategy in reducing a 3x3 to a 2x2 to a 1x1. Take that solution from a 1x1, pop it back into the 2x2. Take those two solutions and pop it back into the 3x3 to get the third solution. All right, go take a break, then come back and let's do some more.